A humanoid robot company backed by OpenAI called WhatX Technologies just announced a breakthrough showing their robots can now do tasks autonomously. Its robot named Eve can now take more actions thanks to special neural networks, which allow the bots to learn by watching videos of people doing activities. From this, Eve learns to copy the activities on its own without needing complex programming. What's very interesting and exciting was it only took 30 Eve robots to train the bots to do these tasks autonomously. How big of a deal is this? We've got Dr. Scott Walter joining us, and he's a two-time robotics company founder. Thank you so much, Scott.
Thank you, Herbert. I think this will be a rather interesting review.
So every week almost, we do a bot video. We're seeing these bots, all of them, continue to drop videos showing that they can now learn things autonomously. This is something that seems to be happening more and more. So here's the news, right? So 1X, they are a Norwegian company, right? Or from, right?
Correct, from Norway. Mm-hmm.
Yep. Funded $100 million, of which one of their funders is OpenAI. And they dropped this and they just said this: all neural networks, all autonomous, all one-time speed. They didn't speed it up. This is all autonomous. There's no teleoperation in this video. They had trained it to do all these tasks. And this is Eric Zhang. He's the lead VP of engineering for that company. And he said, every behavior you see in this video is controlled from pixels to actions without a single neural net with a single neural net architecture. So there's no coding. This neural net learned it on its own after it was given videos and doing teleoperations. Now in this video, there's no teleoperations, no scripted replay or task-specific code, no CGI, all in one continuous video shot. I'm going to go ahead and play this video. And while I do, please tell us what we're watching.
Okay, so the first thing, of course, you see here is a very simple operation of being able to move parcels in and out of different pallets on a conveyor system, get an idea of the functionality, reasonably smooth, and you see it's got the mobility that's needed for a task. Now, if you just pause for a second right here, the first question that kind of came into my mind when seeing that, it's like, oh, okay, I see just a couple of bots. But then as the shot turned around, it's like, wait a minute, we're seeing a lot of bots here. So what we want to do is get an idea of how many unique robots there seem to be out here that they are using to train, because this is probably one of the largest collections of humanoid bots that we have seen in one location. And that's very important to the training sets. So the other thing I want you to notice about the operations is that what they're doing requires a lot of turning your back and going in another direction. So it's not like everything is just shifting a little bit to the left or right, but they've got to turn around, get something with the back, come back and forth and back and forth. And as I've looked at the mobility of a lot of the humanoid bots that are bipedal, a lot of them have not convinced me they can turn really quickly. They are still kind of slow going straight ahead, but they seem to be being slower kind of being able to turn. So in this case, having a mobile base, which is wheeled, they're able to do that movement a lot quicker than you're normally able to do. And of course, it makes it a lot easier for them to do the mobility and the navigation that's needed for a humanoid bot. So they've decided, okay, we're going to forego figuring out how to do the walking bit first, and let's work on having a mobile base. Now that limits you, right? It means you have to be on a level floor the whole time. So let's continue on. Let's take a look.
Yep. And not only do they not have legs to walk, they also have pinchers as hands. So
as
that
hands, they're not fully developed hands. Correct. So we'll go ahead and we could see they're learning to do those operations. Now, if you pause for a second, I just said, aha, a level floor, right? Well, you can put ramps in here and it's able to go up and down ramps. So you won't be able to have steps, but you might be able to reconfigure your environment to have slight ramps like this if it needs to go up and down. And we see later on there's elevators. So there may be a lot of situations where it's okay to have robots that are on wheels moving around. It don't require as much power. And you see they've got kind of a clever solution that I kind of refer to it as being kind of like a snowboarder. Your feet are kind of trapped in there, but you still can go up and down if you need to, which we're going to see here. So at first, everyone thought like I did, it's like, oh, they're over, doing spinning or working out, right? No, they actually are recharging and they're able to plug themselves in and out, and you're able to see they can use the legs to adjust the height as necessary.
What are they plugging into?
It looks like just a standard outlet.
The hip?
So
no, but is it the hip?
Yeah, it's hard to tell whether there was something down on the base of it. So right there, I'm not sure if it's plugging in at the base of the wheels
I see.
or whether
Yeah.
there's somewhere else on there. But I had a feeling it's down low because that might be where the battery pack is. Now
I
that
can see
makes
that
sense
cord.
to
Hmm.
probably put your battery pack down low
Hmm.
because that means your center
The
of mass
base.
is really low. Yeah. And so you
Hmm.
have a lot more stability that way. So there might be something down there.
There
Yes,
it
it looks
is.
like something is
It
clipped
is.
in down there in the bottom.
Yeah.
Okay.
It's by the
So
wheel.
yeah, so we can see that they're able to self-charge. And then we have another room over here. We expect they're going to be doing something very simple. And you go in there, and I think there's a little bit of a surprise. It looks a little bit more like a bedroom. If this is the
Hmm.
one that I remember, and yes, over here. So we have a
Yeah.
living room or a bedroom where now we need to pick up things off the floor. So it does show the ability to be able to go down because it is partially legged, even if it's not using the legs to walk,
Hmm.
identify different objects. And again, they're saying this is end to end, pixels in, motion out. So they've probably also figured out some of the same tricks that a lot of the other AI companies have regarding VLMs being able to do training with vision system models of, like they said, video in for training sets. And a lot of different tasks that we see going on here. I think over there was going up on an elevator. Again, we can see some of these doorways have ramps on them to allow them to go up and down as necessary. Um, Actually, I'm not surprised to see these ramps because in Scandinavian countries, a lot of the offices, the way they're set up, they usually have a little step in between there to prevent drafts because it gets very cold. So you get used to that.
Hmm.
Like when I'm in Finland, Sweden, walking around, sometimes you almost trip going through the doorway. So they probably had to make a ramp just for that in many cases. Okay. So again, we're seeing what looks like another room there, this office space, a lot of chargers around there. So it seems like maybe they need to charge frequently. I don't know how often,
Hmm.
how long they can run. But in some of the workstations that we're going to see where they're doing these tasks, they are plugged into the wall. So they are showing us a couple of modes. One where it's
Hmm.
able to run around fully autonomously without being plugged in. And in some cases, I think down here, they may actually be plugged in while they're continuing to do
Hmm.
this. This is an interesting kind of what I would just call a Sisyphusian kind of task of constantly rolling the ball uphill and then it only comes back down again. You got to do it again and again and again. But that's where they're getting more and more of the training sets. And I did make a little pun about the name because I said it was at 1X. And I said, of course, you would expect nothing but 1X from 1X. So I could remember the company name. I kept on getting it X1. It's 1X. Okay. It's 1X.
Hmm.
So if you want to remember the company name, that's one way of doing it. But it's important to see that that is the normal speed. It seems you're not super fast, but let's just say is able to do the task close to what you would expect from what a human would be able to do. Especially if you're doing the same task repeatedly over an 8-hour day, you're not going to be just going full out, full out, full out. So there's the first thing I wanted to figure out was like, aha, this is what the first time we have seen a lot of robots that are training because the expectation is you're going to need a lot of real world data to be able to improve your training sets. And I counted, I think like 24 robots when I went through that scene, but I wasn't sure how many of them I double counted. So I may have double counted anywhere from 4 to 6, something like that. So maybe there was 20 unique robots in there. And everyone else can do that at home, go through, see how many you can count. But it is a fairly large number, and it means that they are trying to capture that real world data. If you remember, we had a nice little discussion with Suzanne Gildert from Sanctuary last week, where she explained a little bit of the process that they're doing. And there's a big difference between sort of the simulated data and maybe even the telerobotic data that you would be using in your training sets. And then when you start to deploy it on the bots, because when you simulate, you are simulating in an artificial environment where the physics are simulated physics, they're not real world physics. And that means you get kind of close to your solution, but it's not a perfect solution. And you need to then go out there and refine the model by doing a lot of reinforcement learning on what you have learned from the simulation to get the model to be a little bit better. And it looks like that's probably what they're doing there.
Right. Okay, so this company has actually dropped a number of videos. Before we go and watch those ones, I wanted to kind of read the write-up that Eric did in addition to that video we just watched, 2.5 minutes here, just to see what they're saying. So like we've already said, this is all 1x speed. They did not speed this up. So that's decent speed, right? What did you think about the speed? Felt like it's workable with just that speed. How many miles per hour do you think they're going?
Oh, they could be doing probably a little over 2 miles per hour, not quite three. Yeah,
Seemed okay, right?
yeah. It
Okay.
seems to be close to what you would need to be able to operate in some sort of factory
Mhm.
environment about that speed.
Because it's wheels, it's going to be easier and faster for them versus the robots that walk. Okay, so it looks like that 1x, the abundant supply of physical labor, very similar to everybody else. We designed our hardware to take after the human form for maximum generality, general approach to autonomy, learning motor behaviors end to end from vision using neural nets. This is what everybody's working on now, the neural networks. Every behavior you see in the above video is controlled by a single vision based neural network that emits actions at 10 hertz.
10 hertz. Yep.
What does that mean?
Oh, that's the frequency. So getting an update 10 times a second.
Okay. So
Yep.
neural network consumes images and emits actions. So just walking around, but now it's been trained. So it kind of knows, but it's looking at what it's looking at and knows what to do. It drives the controls of driving, the arms, the gripper, the torso, and the head. The video contains no teleoperation. Everything we just saw there was actually autonomous. No computer graphics, no cuts, no video speedups, no scripted trajectory playback, all controlled via neural nets, all autonomous, all 1x. So this was interesting here that to train the machine learning models, they only actually had to use 30 Eve robots. So they would feed it video, they would do teleoperation, and once they did it with these 30 robots, it built a base model to understand a broad set of physical behaviors, cleaning to tidying homes, picking up objects, interacting socially with humans. They also say, by the way, that you can just talk to it because they're partnered with OpenAI. So you can just say, go pick up those toys and it'll know what to do. And a model for general door manipulation, which I'm going to show while you're talking here, and then solving specific tasks, how to open specific doors, right? Notice that it has specific doors. So they have had to train it for that specific door. But it can onboard new skills in just a few minutes of data collection and training on a desktop GPU. So they were all trained by teleoperators, software 2.0 engineers, who express. So what that means is that the engineers don't actually code anything. What they're doing is coding the neural nets and letting the neural net learn on its own and it codes itself. So our ability to teach our robots short mobile manipulation skills is no longer constrained by the number of AI engineers. It's actually just code constraint or computer constraint. So talk a little bit and I will show video of other video that they've dropped in the past.
Okay, so I think this is one we saw maybe close to a year or so ago when they first announced their partnership with OpenAI, because no one had really known of 1x except probably people who were very close to it. They were almost in stealth mode, and now we're starting to see more and more of these updates because I've wondered what they've been doing in the past year, and it looks like they're coming up with a similar approach that everyone else is. They're doing end to end. They're beginning to find that the way to train these is also very similar, in that vision in, and then the motor profiles out, and exactly what the actions are supposed to be, with very simple training sets. And it's very similar to the results that we're seeing also coming out of Sanctuary, and also I think Figure with the demonstration they did with the Keurig. So they're all beginning to realize that it is really feasible to start training these bots. And what I think is probably important here is that some people may say, well, okay, it's a very simple bot. It's not really walking this and that. That's not so important. What's really important is that you can train these things. If you're able to get the brains together, the rest of it is something that you can take care of later on. Now, it helps to get something that's maybe closer to the human form factor to be able to do it, but it's probably close enough. How much effort do you put into the hardware? How much effort do you put in the AI? They put just enough effort into the hardware to start collecting data. And as we can see, it was able to operate in that sort of factory warehouse environment pretty well going around. And what we haven't shown there, and what we've seen a couple of posts of, is they have a new robot, which is called Neo, does mean new, that has what looks like fully formed hands and bipedal legs. So it will probably, we haven't seen a demonstration of it walking or anything else. They did show grabbing a coffee cup. So it looks like they finally have that. So, they recognize that those old claws, that's not going to be the final form, that maybe the wheels is not going to be the final form, except in some certain limited use cases. The main thing is that they seem to be coming up with similar results as everyone else. And that excites me to see that they're all being able to say, hey, this approach we're taking seems to be giving pretty good results and giving us good results very, very rapidly.
Yeah. So they can train it. That's key. But like you said, it just has the pinchers now, and everything we saw is great. But it's pinchers. Pinchers are limited. But you're saying that yes, they have Neo, but it's going to take a lot longer. I would guess for them to figure out the hands because they're
probably
nowhere near.
More retraining. I would think that they would have to go through in that, but they may have the architecture together to realize, this is how we get the data in and data out. But the real thing is that it has to understand what the hands are doing now. So it's going to be a bit more complex task. It's going to be like a lot of rework, like what we've seen before with, even with FSD and others, that if you start changing the automobile that it's in, that we need like another set of training sets in order to be able to get this end to end to work. But it's sort of exciting to see.
That's it. I'm going to play another video and I'm going to listen to the video actually has audio. So let's watch this.
I'm Eve. Welcome to the 1X Kitchen. In this video, to celebrate the winter holidays, I'll share with you how to make my favorite gingerbread cookies. You can also find the recipe in the video description. So if you're ready, let's get started. We begin with adding the butter and the brown sugar in the stand mixer, and blending it together, until smooth. Once that's done, add the vanilla, and the molasses and mix once more until the mixture is uniform. While the mixer is running at medium speed, add the remaining ingredients, 1 cup at a time, finishing with the flour. The mixture should now form a dough. Divide the dough into 2 halves. Transfer each half into containers. Place them in the fridge to chill. This should take 3 to 6 hours depending on the temperature of the fridge. Once the dough is chilled, preheat the oven to 350 degrees Fahrenheit, or 180 degrees Celsius. And line baking trays with parchment paper. Lightly dust your working surface with flour, and place your dough. Roll the dough down, using a rolling pin. We're aiming for a thickness of about 1/8 inch or 3 millimeters. Next comes the really fun part, where we cut the dough into figures using cookie cutters. Transfer the cookies to the baking tray, leaving some space between them. And Pollock.
Okay, I just sped it up. So, so first of all, why did they spend this was dropped just a month ago. They're just showing you that the pinchers can do everything, right? It can pick up forks, it can pick up spoons, it can, even manipulate an oven and look at that. So, why are you spending so much time teaching me that this can do? Secondly, the voice I thought was going to come from the robot, and it's not. It's just an overlay on top of the video. I thought it was great. It was funny, but I mean, what did it show me except that this thing can do a lot of things? And that was probably teleoperated just to tell folks. They did not say that video was not teleoperated, which means that there's a human doing the activities. They were just trying to show you that it can, the future of what can happen.
Show you the ability. And the grippers you see there are actually Robotique grippers. I recognize them. I've had to model them in the past, and I think every now and then you might see a close-up glimpse that you can look at it. This is a company out of Quebec that makes end-of-arm tooling for a lot of cobots. So it's kind of like the go-to solution in many cases for these kind of applications, because they're these nice little parallel grippers that you can also control the pressure on them. So if you were starting a research project, that would be a really good gripper to kind of go with to begin to do the demonstrations. So I'm assuming they're just doing this to get the proof of concept of what's the AI architecture going to look like, and to have some arms that either they may have built themselves, or it's also possible that they've been using some cobotic arms that you can get literally off the shelf that are available on the market, and then just tapping into those control systems to get an idea of what will work and what will not work, and what's your AI architecture going to look like. So if I was doing a project sort of similar to this and deciding, okay, what's going to be important? It's going to be the brains, and can I get the brains to control something? Can I get it to control something simple? And if I can't, then I might kind of give up and say, okay, it's not a valid research project. But if you're able to actually get something that can do this, and if it's able to do it autonomously, then that tells you a lot. If it's not autonomously, then you haven't gained a whole lot of information except to say that we know with a really good neural net we can get a lot of functionality out of very simple grippers. So that's kind of what it tells you moving ahead. What I'm not sure is that when I look at those Endarm tooling there, it seems to be different than the ones we're seeing in the other video. So I think if we try to compare the two, they may actually be different.
Also, I just want to ask you a couple of questions. One is, this was a month ago. We just saw the one they dropped yesterday. The bots do look like that they're already at the point of, like fine tune, right? This is Gen 2, Gen 3, where you don't see wires sticking out. You don't see bulky actuators. I mean, they have huge shoulders here, but, with the clothing that they put on, it looks clean. And then what do you think about the head? And just trying to make it more, happy with the big eyes and smiling face.
That's a big question of what kind of face you want to put on there. Do you want to do a display like this or not? And that's, I guess, personal taste. And whether you use that to kind of communicate. Some people like those things, some people don't. It's not quite uncanny valley, fortunately, and then, the other approach that we've seen sort of Figure and Tesla Bot take is, let's say, a bit more Terminator, kind of like, almost no expression there, emotionless.
Yeah.
So like I say, it's just going to be personal taste. And they've probably felt that by putting something on there, it makes it more accepting in the, like in an office environment, or if there's going to be a lot of coworkers, which is my expectation is that it's going to be a while where you have a factory, which is just purely bots. They're going to be working side by side with humans. So you've got to do something to make sure they're socially acceptable. They're able to communicate. You get an idea of what the bots are doing. It's a lot of the reasons of why the movements of the bots have to be extremely similar. So again, if you look at the hands there, they're different than what we saw in the other video. They're definitely different. And I think about a month or so ago, there was a picture they posted of the arrival of these bots. So they were like unpacking them. So for wherever they were being assembled, they finally arrived. And so they probably decided that we were going to come up with a different design for the Endarm tooling or the grippers, the hands that they have here versus what they were doing originally, which may have been more sort of a research project oriented.
Okay. So I'm going to play a video of Sam Altman of OpenAI and him talking about OpenAI's strategy. We know that OpenAI has invested and partnered with Figure. We know that they partnered with 1X, right?
Mm-hmm. Yeah. Yes.
So let's take a look at what he said, but let's listen a little bit to what he's saying. This was just a very recent interview that he did with Bill Gates.
Started investing a little bit in robotics companies. I think on the physical hardware side, there's finally, for the first time that I've ever seen, really exciting new platforms being built there. And at some point, we will be able to use our models, as you were saying, with their language understanding and future video understanding to say, all right, like, let's do amazing things with a robot.
In a recent interview with Bill Gates.
So, yeah, what do you think? So OpenAI is going to try to give, the technology for this to learn, to be able to speak back and forth, right? To give it I know that in one of the articles it said there that you don't need to have a special phrase or some sort of like, hey, Siri, do this. You can just say, like you would, go pick up those toys and it will know what you're saying. Like it'll know what you're referring to. If you say, bring back the duck, it should be able to go pick up the duck toy and put it wherever you tell it to put it. Like if you say, put it on the kitchen table, I think that's what they said. That's part of what they're teaching it.
Yes. And most of the other humanoid bots out there have sort of taken the same approach. They figured out how to bring these LLMs to make sure you have that interface of just being able to make a suggestion of what it should do, and then it figures it out. Then from there, it has to break it down into whatever the tasks and procedures it needs to do, and then start to execute that. And when it executes it, it's just, again, it's seeing what's out there, photons in, and then actions out. Google talked about that in that paper last spring when they talked about RT2. We've heard it from Sanctuary talking about that. We've been hearing Tesla talking about the similar thing with FSD and assuming the same thing with Tesla Bot. The end-to-end also, Brett Adcock from Figure says that they are doing the same thing. So I'm not surprised to see that they're able to do it as well. And I'm sure OpenAI is very interested in being able to get a platform to work with. So that investment in there was why I was like, aha, okay, it looks like there's a platform that we can start to develop these new models, these new AI models, to see how we can enhance everything. Because you think about a large language model, it's really just being taught on text. It's not interacting in the world. It sort of doesn't understand anything. It hasn't explored physics except for what it may have read about. It's very different to read about physics than to actually experience it. So by having a bot like this, they can start to see what are the limits to being able to teach these different models when you now have a completely different set of data coming in. So the multimodality that they're talking about of that, not just text, but now also vision, and then maybe a sense of touch, and also a little bit of being able to explore curiosity. When you start to build that in there, that if you, a lot of times when you are looking at a YouTube video, it's just the data comes in one stream, one point of view. It's very hard to say, well, what's it look like from over here? You can't do it. If the cameraman didn't change the camera, that's how you see it. But if you're exploring the world yourself and you're curious about something, you can say, well, wait a minute, I want to understand what it is I'm seeing. And then you can move around and get a different viewpoint. And then from that, understand or get a much greater understanding of what's going on. And this also will help a lot with just understanding sensor fusion and what that's going to be like when you start having different data sets coming in that will start to complement themselves to let you know that, when you see these things together, they give you a more complete picture of your environment to tell you how you'd be able to interact with it to fill in missing pieces of information. So again, sensors on your fingers can tell you something about an object you can't see the back of. So if you reach around and feel the backside of it, you might be able to say, okay, but I've seen that something like that that's felt very similar in the past. I can now fill in the picture, complete the picture to know what's back there.
Okay. All right, so let's just review. I'm going to show another video as well from Aloha. So what we've seen from 1X, right? And I want to get your feeling here. Is this a big deal? So they dropped this video showing a bunch of robots wheeled with grippers, but AI. They showed that it's all being done autonomously, 1X speed. They didn't rush it. They had trained it through feeding it video. They trained it through teleoperation. Everything you saw there, and then they videotaped it through one thing. So I think that that's great, but we're also hearing quite a number of other companies showing that too. And they have hands, flexible, very flexible, which is even more impressive when they can see the fingers and hands all moving versus just a gripper. They have feet, they can bipedal walking, and they can also do this AI. Do you think that this was a big drop, big thing that now 1X is ahead of everyone else, or what's your just
general? Oh, no. What it does is I think it reminds everyone that they're still out there, and that they're a potential competitor, and depending upon the solution space that you need, they may be a good fit. So everything's going to be about certain capabilities. Are they able to work in an environment that's going to be far more restrictive, that you can only get it by with the wheeled vehicles. So it's a large TAM. So there could be room for everyone, but I would not say that they're necessarily top tier, but they are a company that you need to take a close look at. And it's exciting to see that, what they're doing has also been replicated by so many others. We've already seen what Aloha has been doing. The fact that
I'll show that next.
The fact that their training sets are so small and they're getting results like, wow, there might be we might be getting to a tipping point very soon where they get enough of their foundational models together that things just take off really quickly. And so suddenly it'd be like, we're not seeing anything interesting. And they're doing really simple little tasks. And suddenly by midsummer, it's like, we didn't see that coming. So and it's like, it's maybe because you weren't paying attention.
This is the big point I think we need to make, which is literally 3 months ago, you and I would do videos and people would scream at us saying, oh no, bots are like 5 years, 10 years away. They're just not going to be able to do things. There's not going to be able to do useful work. And now everybody's dropping 1 week after another of autonomous robots doing pick and place, simple pick and place. We had to try to explain to people in our previous videos where we kept saying, no, I mean, you can have a very simple environment, just like the video we just saw, where the robot's only walking between 5 to 6 feet and it grabs something from one place, puts it to another, or even just sitting on a desk. And there's jobs out there. They can do that. Pick and place, simple, can do it. And people are going, no, never happened, never, 5 years. Here we are. So I think that the speed of training, that's what they drop, which is like you said, others have said, can you train a bot either through teleoperation, which is a human controlling it, and then the bot learning what it's supposed to do, learning the environment, or videos, feeding it videos, and then the bot learns to be able to do it. So I'm going to go ahead and play a video of Aloha. Aloha is founded or funded by Google DeepMind, and they're just 3 PhD students from Stanford, and they showed Aloha 1. You and I did a video on that. Now they just dropped Aloha 2, a video. And what Aloha stands for is an enhanced low-cost hardware for bimanual teleoperation. So basically, it's not a bot. It's a bot, but it's like doesn't have legs. It has pinchers. But what they're just showing here is that through teleoperation, controlling the arms, that you can teach it. And then they said before 50 times, they just do something teleoperate 50 times. It's enough to be able to get 80% accuracy to be able to do that task. They showed things like pushing in chairs, wiping a spill off of a glass, going to the elevator and turning that on. So Aloha 2 significantly improves the durability of the original Aloha, enabling fleet scale data collection on more complex tasks. Everything's open source. I'm going to go and play this, and you tell me what I'm watching here.
Sam Altman mentioned that we
Models as you were
Wrong one.
And well, it looks like they do have quite a few in there, and you can see the teleoperators are becoming very skilled at doing very dexterous tasks. So, I mean, that's being able to throw and catch something is rather interesting. And if they did it enough times, it'd be okay. There's some incredible dexterity of being a pickpocket. Everything, including returning it to the pocket.
Yeah.
So it shows that again, not the best fingers or hands, but you're able to do a remarkable amount of stuff just because you have a really good neural net that is controlling the system. In this case, it's a human neural net. But if you get enough training data and it's able to then replicate this, that will be amazing to see that. So they've got a fleet of these things. As we can see, there's not just one out there, there's a lot of others because they refer to it as being low cost. And these arms are not being built in their lab, but they are commercially available. So there's a provider these arms are able to get them from, put them together. I think the total cost of the arms might be somewhere around $30,000, something like that, for the setup. That means you can scale that quite a bit and get more and more training data. The main thing that I think is impressive is how skilled the teleoperators have become at this point of being able to do it. I mean, it must take a while to be able to learn how to do that remotely and to get an idea of, the finesse that sometimes has to be there. So a lot of that finesse, of course, comes from our hands, and they've probably got a little bit of feedback from it, but you're not getting full feedback. Quite a lot of it is really going to be coming from the vision system. How much you're able to do just from looking at it to understand it, because we as humans really understand the world quite well, just purely with vision. And from that, we're able to change and adapt what our bodies need to do to achieve the particular goal that we want to have. So I'm sort of wondering is that they probably have a good vision system attached with this as well. So it also understands what does it need to do to make those fine little maneuvers to be able to in this case, I think, that looks like for contacts, right? So you're dropping in some contacts there. That's not an easy thing. Now,
can I ask you something though?
Yeah.
So sorry, I want to. You keep seeing these things as 1 times teleoperated, 5 times teleoperated, and I think they're just showing the grippers, how they improve the grippers. They have a little bit more fingernails. They have a little more. So 5 times teleoperated. What does that mean? 5 times. So they operated 5 times, but it's being teleoperated right now, isn't it? Or is this an autonomous situation right now?
That's what I wonder is if it was like only took 5 shots. In this case, it looked okay. In that case, it's more complicated. So maybe after a training set of just 5, they're able to do it. The other one looks like it was kind of 1 shot. So,
so you're saying that they teleoperated 5 times to pick up this thing, and then this is now autonomous.
It looks like autonomous was able to do it. Yeah, that's what I would think.
Okay, because otherwise I don't know why they're saying teleoperated, like how many times.
So I think if you were seeing up the inset up in the corner there, they're showing it kept on slipping. So before they had a hard time being able to do this particular task. Now it looks like it. So they have a much simpler. So 1 time teleoperated. I'm not sure what the activity is they're trying to do there. They are showing how you have the arm which controls the other arms remotely. So 20 times. So it took 20 times to be able to teach it to be able to do this particular task.
Yeah, I don't know. I don't trust it. I don't trust that this is what we're watching is autonomous, because everything else is, look at this. They say 8 times teleoperated, right? 8 times, then 3 times.
Yeah,
What are
3
they
times.
talking about? Because you got a human here.
If it really, it would be able to pick the pocket after 3 times. I'd like to see it run autonomously, because
Right. They should have shown it without the human doing it. Otherwise, it's a human doing all of these tasks. I don't understand what I'm watching, honestly. So if
they were able to do that in just a training set of 5, and then it was able to then do it autonomously with high repeatability afterwards, that would be impressive.
Yeah. So they did not say anywhere here that something's being done autonomously. I mean, obviously in the previous videos, they did, right? When we watched the previous videos, they showed that after it being done 50 times teleoperated, it was able to then do the task.
Mm-hmm.
Now I don't know what this, because, you know what I mean? I don't understand. This is teleoperation right here, what we're watching. So I wish that they had done this and then showed it being done autonomously afterwards. Otherwise, I'm not sure why they're not showing us autonomous.
Mm-hmm. Yeah, I agree. It's hard to tell. And you could only tell from that vantage point. Some of the others that we're seeing here is, one time teleoperated, and then was it able to repeat the task after just one shot?
Yeah. Okay. And I guess the point being that we just said, here's 3 grad students. You will love this. Grad students, PhD students from Stanford, funded by Google DeepMind. They're just trying to say that, hey, we don't have to be that expensive. I can create a very cheap, simple thing, in this case, just robotic grippers, but it can do so many things autonomously after we've trained it through teleoperation. That's why they designed this thing to be very set up to be teleoperated. Then they let it loose to do things on its own. They're just showing that you don't need to have fancy robots to do something useful. In this case, they're showing things at home.
Right. And I think that's part of the point, is they want to see the absolute minimum that you need is like some form of mobility. You can either make it legged, or you can put it on wheels or a cart, which I think is what Aloha does. You need to have 2 arms, and you need to have some sort of gripper. Doesn't have to be a full hand. So that's like the bare minimum of what you need. And even their arms are only 6 degrees of freedom. They're not like full human arms. So they're lacking a little bit of that. And then a camera system. Then if you have that, now you're just trying to demonstrate how good a brain can we come up with. Yeah. Again, I've said, okay, if you put a really good neural net in there, i.e. a human, that means you can do some really remarkable things with really lousy fingers. Yeah. Okay. And that's very good, because we've got better hands than what they have. They're not perfect hands, but we can see what Figure has come up with, what TSLA has come up with, what Sanctuary has come up with. They're not human hands, but they do have 5 digits. They're able to move around very similar like the human hands. So that tells us that, now that they have even better hands, if you really get that neural net up there, then there's hope that you would be able to do a lot of these very complicated tasks. So that's the question it's answering for me, is like, are the mechanisms good enough? How good of mechanism do you have to have in order for it to be able to do complicated human tasks? And it turns out maybe not that complicated. All you need is a really good neural net. And if you can solve that problem, then you've solved it. And then you can do anything. And then you can start talking about refinements and improvements of how we can get slightly better dexterity, because now we want to do, we want to literally be able to thread the needle. It looks like you can probably thread a needle right now with almost what's out there, because there is very close to enough control. If you can pick a pocket like that, if you can get the contact lenses in there, boy, you're pretty close, even with just little pincers like that.
Yeah. So, the advancements of AI is so fast. And Sam Altman said a couple of things that is very interesting, that it pertains to what we're talking about right now, right? The first he said was, if you think about AI, language learning, LLM model AI that we've all watched, a few years ago, people thought it was impossible. And then when you ask them, they would say the very first thing it'll be able to do is, oh God, I'm mixing this up now. The last thing it'll be able to do is creative things, to be able to make images, create video, create art form. The second to last thing would be the hardware. That's going to, or the second to last thing would be the ability to do the complex math or the speaking to you, the reaction to you and answering back questions. But the easiest thing would be the hardware. And in fact, it's the complete opposite.
Yeah.
Creativity was the first thing we saw, images, great images, paintings, poetry. First thing came. Then second thing that came easily next was the ability to, as we are now, typing in answer questions and then the answers coming back. And then the third thing we're working on is hardware. And so it's funny because we then heard a few other robotics people saying that at first they thought that the hardware was going to be the easiest thing. And then it was going to be the brains that's going to take us forever to figure it out. And now what we're finding out, they're saying, is that the brains is actually coming much easier, that you can show these teleoperation training, you can do the video in, and it would be able to do tasks. And so the actual AI itself, the neural net, is progressing faster than they realize. And it's actually the hardware right now that they're trying to make it, quicker, but it's going to come. The hardware is definitely going to come so that it's scalable. And so the question now is, what is the rate limiting step, do you think, in your mind?
Well, I think right now is that it's a hardware problem, but it's a double hardware problem. Part of it is getting the robots to be reliable enough and to not consume that much power so you can get a reasonable lifetime out of it. The other is the compute needed to train the AI. So right now, I think everyone's like, wow, all we need is like this much compute and we probably can solve the problem with all the data. So they're probably seeing it that way. And, I did say that when I first saw the Tesla bot presentation, that in this case, the prototype will be hard and the production will be easy because the hardware is relatively simple problem. Not that there still aren't refinements and some advancements in there, but overall, it's pretty crude compared to what the AI is doing. I mean, that is absolutely remarkable. And that seems to be progressing pretty fast. And when we first saw the Tesla bot project, we had not really known what was going to happen at OpenAI. We didn't know about ChatGPT 3, 3.5 or 4 and what they were going to do. And now a year later, we really understand that much better, that the AI is progressing very quickly. Now we're going to the embodiment. We're seeing not just 1 or 2 or 3, but it looks like 4, maybe
30,
5 different
here.
companies out there that are making remarkable progress already. And it's like, here we are. Oh, it's Valentine's Day, mid-February. We're only in mid-February. And we've already, I think, seen a lot of exciting results in 2024. So it's going to get more and more interesting as we get towards the summer into the fall, and we're going to see a lot more breakthroughs. That I'm pretty sure.
Right. And so we've been hearing that there's going to be a handful of robots. Here we've got this company saying that they have 30 robots. That's the highest number we've heard so far. We expect to be hundreds by the end of this year, thousands the next year, and then hundreds of thousands the following year. But it's progressing faster than we all think. And we're now in the hundreds this year for sure. Like in the next few months, we're going to hear that there's bot companies making not just 10s and 20s. Like in this case, we already seen 30.
Yeah.
So
You'll see more, and you'll start to see those numbers because you need the real world physics. And that's something that Suzanne Gildert explained really quite well, that you need to simulate it first to get your base model. So the robot has something to do. The way I think of it is like, we're born with a lot of innate capabilities, and those innate capabilities allow us to learn. But if we had a blank slate when we were born, we wouldn't be able to do anything. So you got to make sure your bot has like some understanding of how it's able to function. And that's taught in the simulation, because you need so many iterations to be able to do it. And then you like to give it to it. So it's like, okay, now start learning from there. Yes, in theory, you could build a bot, a hardware bot, and just have it keep on trial by error to learn to walk. And it would just take forever. So you've got to do that in the simulation. But in order to do it in the simulation, you need to be able to have reasonable physics models in there. And those reasonable physics models are not quite good enough to do it. They can do some things. And Suzanne said that they're able to do some one-shot simulations right now, so that they can simulate a particular task for the bot, put it on down there, and it does it. And it does it all the time, because the particular use case they're doing, they can model the physics really well. But when you start getting more squishy things and soft things like fabric, things like that, that's really hard to simulate and to get right the first time. So you can get something in there and the bot will try to do it, but then you need to do it again and again and again. And The only way you can do it quickly is you need to scale up the number of bots. Either you have one bot and run that bot for like years and years doing the same task, or you get 1,000 of them and then you run them for 1 year, and now you've got 1,000-year training set right there. So at some point, the scaling is going to be inevitable because the simulation will only be able to get them so far as the physics.
Yeah. So, and they showed that you need teleoperation to show picking up a pawn in a chess set, for example, and now it knows what a pawn feels like, how to actually do it too. Like they did simulation to try to speed it up, and he goes, "Oh, I'm, just randomly the bot will try to grab it this way, and they'll try to, it'll spill it this way, and then eventually figures out that this is the easiest way." Feeding it video, doing simulation, and then it figures it out, and then that's not enough. You need to have the physical hardware through teleoperation so the bot can actually feel for itself what that looks like, not just simulation where it goes, "Oh, I should do it this way." It needs to feel for itself to know how to actually do the actual movement to grab the pawn and move it, that action. And then once they do it a bunch of times, now it knows to recognize that it's a pawn. It knows how to move its hands in there, not spill all the other plate pieces, grab it properly and move it properly.
Right. And a lot of times, and you need to do it a couple of times to get an idea of what the variability is, because not all objects are the same. They may look the same, but they're going to be a little bit different. So again, every bottle is a little bit different. Some bottles are full, sometimes they're not. And so there's a slightly different feel. So you have to understand what's the variability that's in there to be able to expect what's going on. And, knowing what kind of friction you're going to be expecting on surfaces and everything. So when we walk, we have a pretty good idea when we see a surface of what to expect. So when we see what looks like a slippery surface or slope surface, we react to behave very differently because we've learned, literally learned by falling over and everything else many times. It's like, oh, you got to be careful when it's slippery. We understand that some surfaces we can be more confident on because the friction just seems to be right. Or, it's like a surface that we were confident on yesterday, but now we notice it's a little bit wet. So, okay, maybe you want to think about that. So these are all things that you've got to bring into the training set. You can do a little bit with simulation, but it's something else to actually go out there, put your foot on a slippery surface and feel what it's like to go.
Okay. Just to clarify one more time, because people always jump on us all the time. The bots are not close right now. It's going to take years for them to get out to do general humanoid work, useful work. General meaning that it can do lots and lots of activities. But for simple tasks like pick and place, you already have bots today, like Digit, that can walk, can grab a parcel, move it from one place to another. That exists today. You can see these bots here today. They can do things. You just watched that video at the beginning. So there's certain simple tasks that you can already use, but what everybody's chasing after is the generalized humanoid bot, the one that can do anything. And it needs to be trained significantly to do true useful work and in factories and others. And that will still take a lot of time. We're not saying that it's going to happen next 6 months, but just clarify when we say something like, of course there can be a bot in the factory today. Of course there is. There is already humanoid bots in a factory today, but they're doing very specific single tasks. That's not the challenge. The challenge is creating the ability to be able to do all sorts of things, not just one thing. So
absolutely. Yep.
Okay. Thank you, Scott. That was fun. I loved it. Thank you for reviewing that. We do this video almost once a week. We find all the bots out there. Follow us on my channel, Brighter with Herbert, and we have a robots playlist. Scott and I have done over 30 videos, and we will look at all sorts of bots, Chinese bots, wheeled, non-wheeled. We've done all sorts of research and deep dives. And if you have one that you want us to look into, please send it our way. We'll do that as fast as we can. Scott and I are also going through a series of interviews directly with the CEOs or COOs of these bot companies. And we've got a number of those scheduled as well. So stay tuned. Thanks, everybody. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.